Today, we will try to understand the working of Whitworth quick return mechanism, which is one inversion of slider crank chain. Here, we have fixed link number 2 of a slider crank chain. 1, 2, 3, 4. This is a slider crank chain. Now, here we have extended this link number 1 up to point C, and we have used one extra link number 5, and at the end of this link number 5 we have attached one slider which is link number 6. Now one cutting tool is attached with this link number 6, and this stroke line of this D we have taken in such a way that it passes through this point O. Now we will see that this slider will reciprocate like this, and during its forward stroke it will take more time, during its return stroke it will take less time. This is the objective of a quick return mechanism. That means during return it will take less time. So how it will work? Let us see that. Now point B, this will rotate about point A. So let us draw the path of B. So we have taken A as center, AB as radius, and we have drawn this path of B. Similarly, here if you see that point C, this will rotate about point O. So again we have drawn path of C, taking O as center, OC as radius, we are drawing this path of C. Now for extreme positions of D, that means extreme left position and extreme right position of D, position of B will be on this stroke line. Also position of C will be on the stroke line for extreme left position of D or extreme right position of D. Because you see carefully, here this extreme position of D, let us say extreme left position of D, we will get when the C point C will go to C1, then we will get extreme left position of D. When C goes to C1, as COB always will be on the same line, so corresponding to point C1, B1 also will be on line C1O. That means B1 will be here. Definitely it will be on the path of B and also on the line C1O. So B1 we have obtained. Similarly, B2 also we can obtain. So how we can obtain C2 and B2? That means position of B and C corresponding to extreme right position of D. So for that, what we will do? We will try to obtain this position C2 at first. So position C2 will correspond to extreme right position of D. So extreme right position of D will be obtained when C will be on C2, and when C is on C2, then B will be on B2, as C2O B2 always will be on the same line. So position C2, C1, B2, B1 we have obtained. Now we can have D1 and D2, that is extreme left position of D and extreme right position of D. How? Length CD is fixed So what we will do, we will take this length CD like this. With the help of one compass, I am taking the length CD. Now as we have obtained position of C1, so taking C1 as center, CD as radius, I am cutting on the stroke line like this. So we have obtained position D1. Similarly D2, how we will get D2? For getting D2 again, I am taking C2 as center and CD as radius, and I am cutting on the stroke line. So this point will be D2. So slider D will reciprocate between D1 and D2. But you see, this will rotate like this. So link 3, this rotates like this. So when it goes from B1 to B2, when it goes from B1 to B2, point C goes from C1 to C2. That means point D goes from D1 to D2. So when point B1 goes to B2 through this path, this angle is front angle, responsible for movement of slider from D1 to D2, and during return from D2 to D1, the corresponding angle will be B2 to B1 like this. So this is return angle theta r. So as theta f is much than theta r, so time taken for D1 to D2 will be more, and from D2 to D1 will be less. So that is known as quick return ratio, QRR. So QRR will be equals to theta f divided by theta r. And what is theta r? Theta r again can be written as 2 pi minus theta f. So it is theta f divided by 2 pi minus theta f. Thank you.